Students, in this class we will try to understand the Descartes' rule of sign. Now we are given a question, p of x being equal to x positive 1 multiplied with x negative 1 times x negative 2 times x positive y times x negative I, and we are given that the following are its zeros: negative 1, positive 2 and negative I and positive I. Now if you were to see the number of zeros, in other words the number of roots, there are positive roots and negative roots and complex roots, okay, or imaginary roots. The positive roots are two numbers, or 2 in numbers. The negative root is 1 in number, okay, 1 in number, or you can just say in quantity, and the number of complex roots are 2 in numbers, okay. So now by Descartes I'm going to exactly show you how the roots are correlating with the observation or the inference made by Descartes, okay. So for that we need to obtain the polynomial. So I will be multiplying x positive 1 with x negative 1, that is going to be x squared negative 1, and I have x negative 2, so I will have to do the multiplication. But before that I can very well multiply x positive I with x negative I. That would give me x squared negative I squared, but I squared is negative 1, so that's going to be positive 1 to me. So I have got x squared negative 1 here and x squared positive 1. That would give me x to the power 4 negative 1 followed by x negative 2 multiplied. So if we were to multiply this, I would be getting x to the power 5 followed by negative 2x to the power 4 negative x positive 2. So therefore the polynomial is x to the power 5 negative 2x to the power 4 negative x positive 2. Now write down the sign changes, okay, sign changes, okay, write down the sign changes. So we have a positive sign, a negative sign, a negative sign and a positive sign. So from positive to negative there is one sign change, there is no sign change, and similarly from negative to positive there is one sign change. Therefore the total number of sign changes for the polynomial p of x is 2. So this would mean p of x will have at most, okay, at most, that is maximum, at most 2 positive roots, okay, that is the understanding. So 2 positive roots. So clearly we see that there are 2 positive roots given here. Now let us find what is p of negative x. So this is going to be negative x raised to the power 5, negative 2 times negative x raised to the power 4 followed by negative x positive 2. This is negative x to the power 5. This is 2 times positive x to the power 4, positive x and positive 2. So find the sign changes. This is negative, negative, positive, positive. Between first and 2 components, negative to negative, no sign change. Negative to positive, there is one sign change. Positive to positive, there is no sign change. So therefore, the total number of sign changes for p of negative x is 1. So this would mean p of x will have at most, that is the maximum, at most 1 negative root, okay, at most 1 negative root. So if you were to see here, it just has 1 negative root. So this is also is verified. Now there is the next thing you got to know. Now the number of, okay, the number of imaginary roots or complex roots is given by the formula n negative of m positive k, where m is the number of sign changes for p of x, and k is number of sign changes for p of negative x, and n is the degree of the polynomial. Okay, so now if you were to see the degree of the polynomial has a degree of 5. So let me write it down here. N is equal to 5. The number of sign changes for p of x, the total number of sign changes is 2. So m is equal to 2, and k, the number of sign changes for p of negative x, is 1. So if you were to find out n negative of m positive k, that is going to be 5 negative of 2 positive 1, which is 5 negative 3, which is equal to 2. So this implies, this would mean that the polynomial p of x will have at most, okay, 2 complex roots. Okay, 2 complex roots. So clearly you see that there are 2 complex roots here. So that is the understanding that we would have to achieve when we study the Descartes' rule of signs.